So I want to investigate if a point is on, inside or outside of the circle. So if I have this lovely circle, this is my centre and this is my radius. If you can visualise it, sometimes drawing a diagram is the best thing to help you visualise. So if I have this lovely circle and I have a point that's outside the circle, then the distance from the centre to that point has to be greater than whatever the radius is. Similarly, if I have a point and it's inside the circle, then the distance from the centre to that point has to be smaller than whatever the radius is. And lastly, if I have a point on the circle, that has to be the distance from that point to the centre equal to the radius. So it has to be the same size. And that's how we're going to investigate where points are. And again, always do a little sketch or a little drawing. So I have this circle, which I'm given the equation of. I don't know the centre and I don't know the radius, but I know I have this 0.41. And it's asking me to check and see if it's inside. So if 41 is in here. I need more information about the circle. So if I go to my log tables, page 19, and I write out, this is the multiplied out version of the circle formula or equation. So I'm going to write out the generalised form of the equation underneath, and that's in your log tables. So I want to find, I know my centre is minus g minus f, again in the log tables. So I know that from equating my coefficients up here, that 2gx is equal to minus 6x. Divide across by x, you get 2g is equal to minus 6. Divide across by 2, you get g is equal to minus 3. So that means minus g is just 3. I'm going to do the same with the f's. So I have the 2fy is equal to 4y. Cancel the y's, divide across. So I get that 2f is equal to 4. So f divided across by 2 is 2. And minus f is minus 2. So my centre of my circle is 3 minus 2. My radius then, from the exact same space in the log tables, is this formula. So I find that g up here is minus 3. I find that f is 2. And c is the number on its own, so it's take away 4. So that gives me 9 plus 4 take away 4, which gives me 9. Square root of 9 is 3. So I know in this circle that the radius is 3. And I also know that the centre is 3 minus 2. So what I'm going to do is I'm going to check and see what the distance is from my centre, which is 3 minus 2, to the point 41. The key number we're looking for is 3. If it's exactly equal to 3, that means the point is on the circle. If it's less than 3, it's inside the circle. And if it's greater than 3, that means that it is outside of the circle. So we're going to work that out using the distance formula. So your distance formula from coordinate geometry, x2 minus x1 squared plus y2 minus y1 squared. x1, y1, x2, y2, and I'm just going to substitute them. So x2 is 4, x1 is 3, y2 is 1, and y1 is minus 2, just mind your signs. So that's going to give me 1 squared. 1 minus a minus 2 is 1 plus 2, which is 3 squared. And that's going to give me the square root of 10. Not much good to me at the minute because I need to actually work this out in order to determine. So you need to get a decimal figure. And that will roughly, if I round it to 2 decimal places, is 3.16. 3.16 is bigger than 3. So if we go from the centre of the circle to 3.16, it's probably about there. And that means the point is actually outside of the circle.